More legitimate. Good morning,
I heard
everybody.
Welcome to that.
So today,
It looks like we have quite a few questions. You know, this chapter is probably the toughest chapter of the whole year.
what?
I did?
Yes, it
Oh, okay. Which
I mean, it doesn't
means
change it.
we need to spend a little more time on this.
is. Okay.
Alright?
Did it?
We are on 10.1.
Did you finish the MC12 yet?
See, it makes up for
Or
the
Mr.
what I
Park.
do.
I'm trying to concentrate here. Okay, number 7. Can we just put these on the side so I can have room here? 27, 29, 55, 70, and 71. Okay, number 17. Sigma. It says, what's the directions? Tell whether the series converges or diverges. If it converges, find its sine. N equals 0. Gosh, I can't even read this. Sine
And sine to n power.
n. That's what happens when you play iPad before class.
Are you using like iPad?
No. Okay. Now, if you look at a series in sigma notation and you have no idea what's going on, what should you do? Write out the first few terms. Okay, plug in 0. 1. Plug in 1. Sine to the first of sine of 5 pi over 4.
Negative 1.
1 over.
Negative 1 over root 2.
It's 1 over.
Negative 1 over root 2. Plug in 2. So that would be sine of 9 pi over 4
Which is
1 half.
squared.
Negative pi.
1 over 2.
Squared.
1 over 2.
1 half.
1 half.
What?
What?
Yeah.
Negative 1 over root 2 squared.
Oh yeah.
Oh boy.
Wait, 9 pi over
Okay,
4
you know what? You know what? Here, some of you going, what? Here, let's do this then. Plug in 1. Plug in 0. If you plug in 0, you get sine of pi over 4, which is 1 over root 2, to the 0 power, right? Maybe we'll write it like this first. Okay, now plug in 1.
To the 1 power.
Sine of 5 pi over 4.
Which is
Here,
negative.
so what's happening is you got this and this, yeah? Sine of 5 pi over 4, negative 1 over root 2, to the first power. And then, now you got sine of 9 pi over 4,
1 over
which is 1 over root 2
To
to
the
the second power. And then the next one's going to be there, so it'll be negative 1 over root 2 to the third power. Do we need to write out any more?
Next.
Okay, so what do you got? 1 minus 1 over root 2 plus half minus 1 over 2 root 2 plus dot dot dot. Hey! You want geometric series, right? What's the common ratio here? What do I need to multiply to get to the next term?
Negative 1 over
Negative 1 over root 2, and is the absolute value of that less than 1?
Yeah.
So therefore, the sum of an infinite geometric series is simply the first term all over 1 minus r, and I will leave the simplifying to you. So it converges to that number, whatever that is.
Nice.
What the heck? Let's just multiply top and bottom by root 2. Root 2 over root 2 plus 1. That's what it converges to.
Wow.
Okay, number 27. See, look, so that problem was kind of easy, but what did you guys have problems with? Plugging in the numbers, plugging in 0, 1, 2, 3.
A little bit.
So I can just put trig here, and then all hell's gonna break loose.
Oh.
Like AB. AB, I give them double angle identity on every single test, and they still don't know.
No, we got trick. You'll need to do the test.
27. Use the series and the function that it represents from the indicated exercise to find the power series for f prime of x. So in problem 27, it says exercise 21, n equals 0 to infinity, 2 to the n, x to the n. Okay, write out the first few terms. What happens when you plug in 0? Okay, so this is f of x, right? Plug in 0.
1.
1. Plug in 1.
2x.
2x. Plug in 2.
4x squared.
4x squared. Plug in 3.
8x cubed.
I think we got the hang of this. This is a geometric series, isn't it?
Yeah.
Common rate. Remember, anytime isn't this the same thing as 2x to the n?
Yeah.
Anytime you have like something to the n power, that's geometric. Whatever's in the parentheses, that's the common
So
ratio.
it's 1 over 1 minus.
Yeah, but that's not the problem. They want you to find the directions, I believe, I forgot already. It says, find the power series for the derivative of this function. So, taking the derivative term by term, the derivative of 1 is 0. What's the derivative of that?
2.
2 plus
8.
8x plus
24.
24x squared. You know what? I want to do one more. What's the next one going to be? 16x to the 4? What's the next one going to be?
64.
64x cubed. Is this a familiar power series?
No.
Is this is not even geometric, is it?
No.
No. How do they write the answer in the book? Like that? Or they write it in sigma notation? They use sigma notation? Yes.
So 0 to the 0 is 1.
No, 0 to the 0 is undefined.
Wait, so when you plug in 0.
2 to the 0 is 1 though.
Oh.
What?
So it's
You're plugging in 0, no,
to
you're
0
plugging in
to
0
1.
for n, not x now.
Oh,
You're
oh.
plugging in
okay.
0 for n. Yes, for those of you who are wondering, 0 to the 0 is undefined. You know why? Let me ask you this. What is 2 to the 0?
1.
Oh, what is 0 to the 2?
0.
So what's 0 to the 0?
I don't know.
Yeah, that's right, we don't know, it's undefined. However, I don't know, 10, 20 years ago, there was a movement in mathematics to define this as 1.
There's a limit.
Because the limit as
Oh,
x approaches 0 from the right of x to the x is 1, that's why. Because if you draw the graph, it kind of looks like this.
That makes sense then.
Yeah, but it's so, I haven't heard anything,
What
so
about
as far as
from-
we're concerned, it's undefined.
What about from the left?
I don't think there's a graph on the left.
To the right.
That's why you find the limit from the right. So we just gotta write that in sigma notation?
Yeah.
Wait,
But-
can we?
Yes. Probably.
You wanna factor out the 2?
Yeah. Let's do it.
I don't know if it's gonna help. 4x plus 12x squared plus 32x cubed. I don't think it's gonna help. Okay, let's write, so sigma notation, did they factor out the 2? Only need lead notes.
No.
Are you looking at the answer in the back? Cho?
Yeah, I'm looking
Oh, they factored out the 2.
I don't know.
at
how
it.
to-
It says 2n and then nx and 2 minus 1.
Oh yeah, what if
What?
you do like
It says sigma of 2 to the n times n.
Okay, here, tell me what the book says. Sigma,
Two
n
n
equal,
2 or
n equal
1.
1 to infinity,
2 to the n
2 to the n
times n
times n.
times x minus x to
X
the
to the
n
n.
minus 1.
okay, what? Yo, that's hard.
It's kind of sketch. But it's right.
Yeah, that's hard to break down. Okay, they didn't factor out the 2. So what they're saying is that this is 2 to the first times 1
Oh, I can't
x to the 0. How do you break down 8? 2 squared times 2 x to the first. How do you break down 24? 2 cubed times,
4.
no, it says 2 to
Times-
the n times
three,
n.
3, times 3.
3.
Times what?
3, n is 3.
Oh yeah, 3. X squared. 2 to the 4 times 4 x cubed plus dot dot dot.
What kind
Who
of-
can do that?
What kind of madness is this?
Cho? I didn't do it.
You didn't do this, did you?
Okay, the easy part is taking the derivative, the hard part is writing it. Okay, I admit right here, even, that's difficult to write that in sigma notation.
It doesn't say we had to though.
It didn't?
But the answer it gives in.
I know, but the problem doesn't say write in sigma notation.
It's just fine.
It just says find the power.
Alright, okay, there it is. 29, so we're gonna do the same thing with exercise 23. Okay, let's see if we can squeeze it in here. 23. What do we got? Sigma n equals 0 to, nobody's saying E, right?
What?
Every year there's always people going E. That's not E. That's sigma.
You're
That's
not
like,
even drawing it
that's-
correctly.
that's like saying Euler. Negative 1/2 to the n,
Oh.
x minus 3 to the n.
That one gets me confused all the time.
Okay, let's write out the first few terms. Okay, plug in 0. This is f of x. Plug in 0. 1. Plug in 1. Negative half x minus 3. Plug in 2. 1/4 x minus 3 squared. Plug in, what number are we on now? 3. Negative 1/8 x minus 3 cubed. Let's just do one more for funsies. 1/16 x minus 3 to the 4th minus dot dot dot. Okay, let's take the derivative. I'll do the first term, 0. Okay, what's the next one? Negative half plus, come on, put the 2 in the front.
1/2 x.
1/2 x minus 3
Oh.
minus 3/8 x minus 3 squared plus 1/4 x minus 3 cubed minus dot dot dot. Okay, now we need to somehow write this. Okay, let's practice this. Let's write this using sigma notation. So n equals, shall we start with 1 or 0?
1. No, 0.
But then look, this is first power.
0.
So it's up to you, it doesn't matter.
0.
Start with 0. Okay. So let's see, how are we gonna break this down?
Okay, well first it's negative plus negative plus.
This is what I'm thinking. Change the 1/2 to 2/4. Ooh, you guys got that. Change the 1/4 to 4/16. Now the pattern is apparent. Okay, so first, you guys remember this from last year? How do you make it alternate? Negative, positive, negative, positive. Negative going to the n or the n plus 1? N, because if you plug in 0, you want it to come out negative. Okay, and then look at the numerator. How do you generate the numbers 1, 2, 3, 4? N. How do you generate the numbers 2, 4, 8, 16? 2 to the n minus 1, right?
Wait, shouldn't
Wait,
we
it should be
wait,
n
shouldn't
plus
the
one.
n plus 1?
Yeah, right here, n plus 1.
No, wait,
No,
for the
on
power of
power.
the negative 1.
Because if you plug in 0, it's
Then
not
it's
negative.
negative 1.
N plus 1, sorry. N plus 1, 2 to the n minus 1, is that right? No. Not n minus 1. N plus 1. Oh, everything is n plus 1. See, we should have started with 1. Too late. And then finally, x minus 3 to the n. Oh, that's the only one that came out to n. There you go. Anyway, you guys should have experience of breaking down sequences, right? Because basically a series, if you just take, like, you forget that you're adding them up, it's just basically a sequence, right? You're writing the explicit part of the sequence. We did harder ones than this last year. Remember?
No.
Of course not.
Oh, wait. What you doing with that eraser?
She's saying.
Oh, by the way, those of you going on to more calculus in college, when you take differential equations, this is super important right here.
Isn't everybody gonna take calculus or calculus in college?
No, what? No, not necessarily. Like some of you gonna major in biology, pre-med or something, then you're done. No need to take math already.
What?
Well, assuming we get a good score in the AP exam.
How about the computer science?
Assuming we don't pull a Pancho.
Computer science, CIT.
Yeah.
What?
What did Pancho get?
Pancho got a 3.
Hey, that's good enough.
Yeah, that's passing for some colleges, but now, even UH, you get a 4, you don't get credit for it. You gotta get a 5.
Are you kidding?
Yeah.
That's a joke.
So at UH, if you get a 4, you're allowed to take the next class, but you don't get credit for it. You know what I mean?
Why?
That's the way they do it at UH.
Isn't that like? Isn't that like?
On the other hand, at USC, which is Southern California, by the way, not South Carolina, or Santa Clara,
Who would have thought that?
or
Anyone
anyway,
think that?
if you go to USC, you get a 5 on the AB exam. they actually give you credit for the BC exam too.
Why?
Because all the students, they go to USC, they come back in Mr. Park, they placed me in multivariable calculus, and they never did took like the second semester calculus. They get just placed in multivariable.
Wait!
How can they take it?
Yeah.
Like, if they don't.
Move on to the
No, we can't, we're videoing.
Oh, I forgot about
Oh,
that.
no.
Do you want me to airdrop the picture?
Oh, they're.
Who's this for?
Nah, I just need to.
Kelsey, yeah.
I still don't know what you're talking
Wait,
about
who's this
airdrop.
for?
Kelsey.
Your phone doesn't have that.
It's,
Let me see.
you said iPhone. Oh,
Wait, does anybody want it? The picture?
What is it, what is it under?
Today,
Yes,
what
use your
else?
iPad.
What would airdrop be under?
There's no airdrop on that. It'd be under like Bluetooth or something.
Okay, man, how are you using it now?
Settings.
Yeah.
Yeah.
It's not actually on there.
No, you need to press, you need to press
Look, I got Bluetooth, whatever that
Hey,
is.
go to
Oh my
Bluetooth.
god.
No, that's right, you need to press 9,
Advanced,
one.
there, advanced.
and then 1,
Network
and
settings.
call.
You go to your browser.
That's how you connect it.
I don't know what's happening.
Shh.
I'm trying to do the problem. 55. Where's 55?
Orale.
Oh, it's over there. Shh. The sum of a geometric series. We already talked about that. Okay. Find the power series. Come on.
Come on, good.
Boo. I'm gonna boo you right now.
Carlos con pollo.
Well, doesn't this look like the formula for the sum of an infinite geometric series?
Yeah.
First term over 1 minus r.
Oh yeah.
So this just means the first term is x,
Oh,
and the
sorry.
common ratio is
2x.
2x. So how do you write the power series for that? X. And then to get the next term, you just multiply by 2x, and you get
2x squared.
2x squared, multiplied by 2x,
4x cubed.
multiplied by 2x,
Yeah, 8x.
8x to the 4th, dot. And do they want you to write this in sigma notation?
No, boost bread.
No.
I don't know.
I don't know, isn't that pretty easy though?
I don't know. What's the answer in the book? Do I have to turn to the back?
Yes.
No, it's no.
Okay, look, the highest you can get on the next test is 93.
What?
It wants you to
If I look in the back.
No, don't,
It's gonna cost you.
Don't.
No.
So is that the answer, or did they put it in sigma notation?
Well, no, there's no
It's
sigma
sort
and
of,
it's
yeah.
But then you
What?
have to find
They
the
like do
formula for the.
They do it.
And then they're like, two.
Oh, now I get it. Let me see. Yeah, that's it.
Yeah, but that's not sigma notation, but they have.
That
like
is sigma, okay, this is what, that's sigma notation. You know the thing that they put here?
Sigma notation.
That's the thing that's next to the sigma.
But you don't need a
That's-
sigma.
That's the
Oh,
formula.
That's sigma notation.
That's the formula for the
Then
nth
it's very
term.
easy, right? It's
What?
just if
Oh,
you
okay, you know what? We need practice. Sigma n equal, what do you
Zero.
want to start with? 1 or 0?
Zero.
Well, look at the powers. What does it do? 1, huh? Okay, so the coefficient gonna be what? Let's worry about the coefficient first. 2 to the 0, 2 to the 1, 2, here, I'll write 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So how do I generate these numbers?
2 to the n minus 1.
n minus 1. Now, x to the first, x to the second, x to the third,
X to the-
so x to the n. Isn't that what they have? Nemo?
Would have been the same thing with.
Yeah, see, that's the formula for the nth term, that's why. And then, I saw something else, they asked for the interval of convergence. Yes, now when you have an infinite geometric series, the only way it can converge is the absolute value of r has to be less than 1. And what is r? 2x. Can we solve this inequality?
Yes.
Yes,
Wait,
so if you have the absolute value of gorilla is less than 1, that means gorilla is between -1 and 1, correct?
Divide by 2.
Divide everything by 2. That's called the interval of convergence. That means these are the values of x for which this series will converge. So in other words, if I were to plug in like 1/4 for x here, it would converge to some finite number. But if I plugged in like 3/4, it would diverge. Yeah.
So whenever we're solving for the whatever is of convergence.
Interval of convergence.
Interval of
The
convergence.
absolute value of r is less than 1.
So no,
Okay, time out. We did many problems like this in PCH. Should I pull up the worksheets?
No, time in.
Okay, what?
So basically, we can just set the rate.
The
To be-
ratio.
The ratio of -1 is less than the rate, which is less than 1, right?
Okay, I lost you already. If you just do what I do here, nobody's gonna get hurt.
No, but you can always just put -1 and then the rate and then or the ratio and then negative.
Yeah, but that's what
1.
this means, that's why.
No,
right?
I know, but then there's never gonna be when it flips around and you have to do like a
No,
piecewise function or something.
no. Okay, last, oh, I thought that was the last problem. 70 and 71, multiple choice, come on! 50-50 chance. Except for 5 choices.
Yeah, wait, what?
20% chance.
Do it again.
Okay, 70. Which of the following is the function that the power series, oh, okay, do we have to refer to something? Well, here, in exercises 69 to 71, use the geometric series sigma n equals 0 to infinity of x minus 1 to the n. This represents the function f of x. Okay, which is the function that represents, come on! Now, let me ask you this, if they didn't say that this is a geometric series, can you just look at that and you
Because
know
it's something to the
geometric?
end.
Because it's something to the end.
Whoa, you taught me well.
However, for those of you having trouble, write out the first few terms. Plug in 0. Plug in 0.
Negative
No,
0, 1.
Oh god.
Plug in 0 for n, not x.
Oh yeah.
N, see, n. Plug in 1, x minus 1. Plug in 2, x minus 1 squared. Plug in 3, x minus 1 cubed. Hey, you in geometric series. What's the common ratio? X minus 1. See, the thing in the parentheses is the common ratio. But see, when you get up higher in mathematics, sometimes you just don't have time to write it all out. You just gotta know. Okay, so what's the sum of an infinite geometric series? The first term over 1 minus r, and that simplifies to 1 over 2 minus x. That's what the function is. Do we have to find the interval of convergence? No, we just have to find it. Come on, Cardo!
What?
And then 71. See, you know what the problem, this is what I think the problem is. I'm just gonna rant since the video is on. They don't cover this in Algebra 2 honors anymore. In Algebra 2 honors, they used to do so much more stuff, like sequences and series, but you guys told me last year you guys didn't do it, right? In Algebra 2 honors. Permutations, combinations.
Wait, what's the
No.
last?
Oh, Algebra 2 honors was a long time
See,
ago.
that's the problem with American education. That's why Finland is so far ahead of us.
Wait,
It's
what?
not because of video games.
Who? Finland?
Probably.
They play video games too.
It's not-
I heard in Finland, video games are outlawed.
I heard in some European country they don't have.
That's a bunch of BS.
Why Finland?
Finland.
No, why is Finland so much better than us?
Wait, where?
Finland. They're number 1 in the world.
Finland or Finland?
Finland.
Oh.
Do you know that the name of the tune of our alma mater is Finlandia?
Yes. Written by Sibelius.
You know that, Cameron? Of
71.
course I did.
Which of the following is a function
Deutschland.
that the integral from 0 to the f of t dt represents?
Whoa.
Okay, now we're gonna integrate. Okay, they have closed form here. Okay, so integrate. Now remember, you can integrate both sides. Okay, so here's f of x, except they put a t, it doesn't really matter. So we're gonna integrate from 0 to x here. So instead of x's, they're running t's. Is that gonna bother you?
Yeah.
Well, too bad. T minus 1 plus t minus 1 squared plus t minus 1 cubed plus dot dot dot. Okay, here we go. Integrate.
Hey, you forgot d to the t. dt.
Oh yeah. Oh, very good. Just for that, half a point.
Yeah. Wait, that looks like half of a shrine.
But then you're not gonna get it till you get another half,
Wait, what?
because I round down.
So mean.
I'm sorry, that's the way it is.
Wait, what?
Okay,
Oh.
take the antiderivative. Go.
0.
Antiderivative, not derivative.
X.
On the T.
Oh, T.
This is exactly the same problem we have in AB. I tell them take the derivative, they do the antiderivative. I tell them take the antiderivative, they do the derivative. How many times? Okay, next one. Next one. Can I just do this? 1/2 t minus 1 squared?
No.
Yes, because the derivative of the box is 1, so you can. Oh boy. Next one, can I go 1/3 t minus 1 cubed? What about 1/4 t minus 1 to the 4?
Yeah.
Plus dot 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 from 0 to x. Okay, plug in the top thingy.
X.
X minus 1/2 x minus 1 squared plus 1/3 x minus 1 cubed. Now after a while, you can see already, right? You can just go to the
Hey,
next step
minus.
already. What?
Where'd you get minus?
Where? It's right there, plus. Plus 1/4 x minus 1
Don't die,
to the 4 plus dot 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 minus, now what happens when I plug in 0 for t? Oh, it's not gonna be 0. It's 0
He's gonna be.
plus 1/2 minus 1/3
Plus.
plus 1/4 minus 1/5 plus dot dot. Oh, what are we gonna do with that?
Plus dot dot
Geometric
dot.
series.
That's not a geometric
Again.
series.
When he says,
Please.
"Hey, you're a geometric series," it kind of reminds me of Ramon.
Okay, how did they write the answer? Oh, what are we trying to find?
The letter. With the correct answer.
Oh, you know what? I don't think we did this problem the right way.
Let's check.
No. Instead of integrating term by term, why didn't we just integrate this? That would have been a lot simpler. So let's just forget what you saw here. Forget what you saw here. Now we're gonna do this, the integral from 0, because I was looking at this and going, this is crazy. 1/2 minus t dt. What's the antiderivative of this?
Chelsea just kind of like research that one.
What's the antiderivative of this? What's the antiderivative of this? Okay, I'm gonna call on somebody. Kurumaro, antiderivative of this.
Negative ln 2 minus t.
Absolute value. From 0 to x. Okay, plug in the top thing. Negative natural log, absolute value 2 minus x, minus negative natural log 2. Okay, what's the answer in the back? There's no answer in the back. Oh, I see what they did. So they got negative natural log 2 minus x plus natural log 2. So using your properties of logarithms, isn't that natural log of 2 over 2 minus x? Did they just disregard the absolute values? Oh, there's an absolute value there. So they did it. Okay, let's pick out the answer now. Okay, did you guys, oh, look, you guys gotta pick out the answer. Wait, let me look. Oh, so what they did is they flipped it over. So they went like this. Natural log of 2 minus x over 2, but they put the negative power in the front. Is that what they did?
Yeah.
So the answer is, and of course,
Okay, you said that.
the absolute value of a minus b is equal to the absolute value of b minus a. So the answer is D.
It's D.
Is that the answer in the back? Because look, my book doesn't have answers. Oh! Okay.
How come your book doesn't have answers?
Because it's not a
Because I'm just not a teacher.
No, she has answers, she just doesn't know what to do.
Oh. Yeah, I have
Oh,
answers.
really? But dog doesn't like it.
Okay, today we move on to 10.2 Taylor series.
This is a good jump.
Wait, Mr. Vargo.
You know what? I was going through the book and then, I haven't done this for a while, but I went through the book and then a lot of the stuff we're going to find in future sections. I already told it to you, like, at the last lecture. You know, like the telescoping sum.
Randy Pop.
Telescoping sum is going to come up like 2 or 3 sections from now. Remember Euler's formula we derived last year?
No.
Remember e to the ix equals kiss x? Remember that? That's derived in the book, but we did that last year. That's why you guys don't know how lucky you are going through PCA. That's a bargain class. Okay, what the heck is a Taylor series?
Oh, like.
Well, if you look in your book, the Taylor series for a function f of x centered at, this is a definition by the way, x equal a, is simply f of a plus f prime of a x minus a plus f double prime of a over 2 factorial x minus a squared plus f triple prime of a over 3 factorial x minus a cubed plus dot dot dot.
Oh.
Now you know what, I think since, let's practice writing this in sigma notation.
Is there a song or something?
No, this is, well, it kind of, doesn't it kind of remind you of the binomial theorem?
That's the
Yeah,
binomial
but it's not, but it's
theorem.
not, okay. So do not get the two confused. Okay, sigma n equal, what do you want to start with, 0?
One.
You know what, the book uses k a lot too, so we'll just use the k as the dummy variable here.
Wait, can we use anything?
No, that's what they call it the dummy variable.
No, can
What,
we
you see this thing here? We
Why
call
do they
this
call
the
it
dummy, because it doesn't matter what it is, it can be any dummy.
can we use anything for the dummy value with it?
Not.
Well, okay, in mathematics, they usually use n, k, I, or j. Those are the most common ones. Okay, what do you want to start with? What do you think? 0 or 1? I mean, just looking at what's happening here.
0.
Yeah,
Zero.
0 would make sense for this one. 0 to infinity. Okay, what's the formula? F. Okay, just look at these. Look. Look at just.
How do you know
F Okay, just look at these.
Notation for-
What's the pattern that I see right there?
It's the prime is in
Okay,
the-
F, not the kth derivative at A.
X minus a to the.
Okay, but the thing is, what is the 0th derivative? I see,
Over
even
two
that puzzles me,
factorial.
but I guess we just have to assume the 0th derivative is simply just the function itself. Okay? And then, notice that you have x minus a's now. X minus a, this is like to the 0, so you're gonna have x minus a to the k. And then in the denominator, look, 3 factorial, 2 factorial, 1 factorial, 0 factorial. And don't forget 0 factorial is 1, right? By definition. 0, mathematicians have defined 0 factorial to be 1 so that when we do combinatorics, things work out, right? So what's going to be in the denominator? K factorial, there you go. I believe that's written in the book. Did they write it with a K or an N? Not too many people have books, I see.
Okay.
Wait, Mr. Park, I have a question.
They use the K, whatever, whatever, yeah.
So you know when mathematicians like agree on things, like if they supposedly agreed on that 0 to the 0 equals 1,
How do you get people to follow?
then would
Yeah.
our calculator be updated or something, or just?
No, you can punch in 0 factorial on your calculator, it'll say 1.
No, 0
But
to.
like,
What if they
No,
change
0 to
the
the 0.
I don't know, I think you can get error on your calculator.
Yeah, no, that's why. But
Yeah.
then if mathematicians agree that, is there such thing as like updates on our calculator?
Do they all have to agree? Is it like mutual?
it's like a worldwide consensus.
Yes, it would have to be a worldwide consensus.
2/3 majority.
Okay, can we do some examples?
Wait, why?
Write the Taylor series for, okay, let's do one, okay, I'm just thinking.
Wait, what does it mean that it's centered at x equals a?
Because, okay, you know the power series that we learned last year, they were all centered at x equals 0.
Okay.
And it was nice to do that, but sometimes it's better to center the series at a different number because then it will converge more quickly.
What is centered?
Yeah.
Okay, let me show you. Let's write the power series, Taylor series for, what function should we do?
How do you do,
Let's do something we know then. Okay, how about, okay, because in your homework, I think you're doing cosine x, let's do sine x then.
how do you do the exclamation point?
Centered, it's called factorial.
How do you?
Centered at, now your homework, I think you're doing pi over 4, what the heck, let's just do pi over 4. Maybe I'm doing your homework problem, I don't know. Okay, so let's define all the things. What is the function we have here? Sine x. So in order to write the Taylor series for it, notice that we got to take derivatives. We need to compute derivatives. So here we go. What's the first derivative?
Cosine x.
Cosine x. Second derivative,
Negative sine x.
negative sine x. third derivative?
Negative cosine x.
Negative cosine x. Let's just go up to 5, that would be good.
Sine x.
Fourth derivative.
Sine
Don't
x.
forget, if you put it in parentheses like that, that means derivative, yeah? So what?
Sine x.
Sine x, and just one more is good enough. Fifth derivative,
Cosine x.
cosine x. Okay, so here we go. So, this is A, okay? So, what's the first term of this Taylor series? F of A, f of pi over 4. Now, if our function is sine x, what is sine of pi over 4? Root 2 over 2. That's the first term. Okay, the next term is going to be the first derivative evaluated at pi over 4 times x minus a. Okay, here's the first derivative. We look at that. Plug in pi over 4. Negative root 2 over 2. Okay, you guys want to go with... Okay, let's just go with 1 over root 2 instead. 1 over root 2 times x minus pi over 4.
Where did the negative come from?
Yeah.
Oh, I don't know. I don't know. I thought I heard a negative root 2 over 2. I guess not. Okay, here's the second derivative. Plug in pi over 4. Or maybe I was looking ahead. Negative 1 over root 2 x minus pi over 4 squared. Oh! It's over 2 factorial. How should I write that? Like that?
Yeah.
But 2 factorial is 2. Okay, the next term is going to be the third derivative. Plug in pi over 4.
Negative 1 over...
Negative 1 over root 2 over 3 factorial x minus pi over 4 cubed. You guys are getting the hang of it. Let's just do one more. And plus, okay, where are we on? We're on this one now. Plug in pi over 4. 1 over root 2 over 4 factorial, so that's 24. X minus pi over 4 to the 4th. And then, of course, it just keeps going. That's the Taylor polynomial. So, if you are centering it at any number besides 0, we call that a Taylor series. However, if you center it at x equals 0, we call that a Maclaurin series. Okay, I'm bad at spelling. Maclaurin. Maclaurin. I know he's a Scottish guy, so Maclaurin. That doesn't look right.
No,
There's a U.
that's wrong.
Maclaurin.
Yeah, Maclaurin.
Maclaurin. I believe his name was Colin Maclaurin.
You were close.
And this guy's name is Brooke Taylor.
There's a U in it.
What?
You put it in
It's,
a
yeah, there's a U and a U.
In Taylor?
No.
Taller.
Wow.
I put a U there.
Yeah.
Maclaurin, right?
I can't even see.
It's the glare, that's why.
I was just about to tell you a story.
Wait.
Well, can you just-
I read somewhere that these guys actually didn't do these series, but somehow their names are attached to it.
Oh, they did them.
Yeah, what's
Yeah.
about
The Hoptel?
His name is Colin
No, that was
Maclaurin.
Hopital, but this is different.
His name is
And then I
Colin
thought I
Maclaurin.
read somewhere that Maclaurin actually was responsible for Kramer's rule.
Then why is it Kramer?
Remember Gabriel Kramer from last year, Kramer's rule?
Yeah.
Whatever.
The Kramer made
Okay,
it.
so this is how you form that's all you have to do tonight, okay? But tomorrow we're gonna look at the remainder, like what happens when we just do use like the first 3 terms? How close will you be to the actual answer? So we're gonna have to look at the error. And that's when it gets pretty dicey. That's when it's gonna get tough. So tonight is easy. You just gotta follow this, plug in the shot.
Did you answer what center means?
No.
Well, you can center it at any number you
I don't
want.
know what that
What does it
means.
mean by like
Yeah.
centering?
Like pick a number to so that x might instead of centering it at 0 all the time, sometimes it's more beneficial to center it at like 1.
No, like,
No, because then the series will converge quicker.
We don't know what center
What
means.
is center? What
is
is
Yeah.
center?
How do you
mean?
center?
How do you
Like
center
what
a
happens if you
number
center it?
as like x?
Does it orbit 0? Like
No, it's not orbiting. It's not orbiting.
It's like
Instead of x minus 0, you use x minus something else.
What?
Oh.
So that
What do you
number
mean,
is like
oh?
the center because it converges more
Can
quickly.
you give us an example?
Okay, an example would be like, okay, example, if you center it at x equals 0, then let's say you use the power series for sine x or whatever. what if it takes like 5 terms to get to within the error you want? But if you center it out with about something else, then it'll only take 3 terms to get within the
So
desired
instead
precision.
of x, like in the power series, you have like x minus 1.
Yeah,
If you center it at 1.
yeah, so if you center it at 1, then it's x minus 1. So if you center it at x
So
equal
if-
a, that's why you
So
have
if
x
I
minus a.
take like
Are you, like,
less
shifting the
terms,
graph?
Yeah, so
then
if,
the-
yeah, so if you center it at a more appropriate number, then the series will converge more quickly. You can use less terms to get the desired precision.
I know where to.
Yeah, well, that's another thing,
Wait,
and
so
that's a
do you
whole
use
nother
the
animal.
Same like precision formula we learned last year for these.
No, last year was always centered it at x equals 0, you just didn't know what center it was.
Wait,
It's the part we still don't know what
Is
center
it
it is.
I
shifting
think
the
she's referring
graph
to
or
like
something?
Leibniz's theorem.
Oh, Leibniz's theorem is 2 board sections, that has to deal with alternating series.
Yeah.
Okay, you don't need to worry
Wait,
about that
so
though.
when you center it at 1, does it like shift it up or something?
Shifts it to the right one.
Oh, I get it, I
Yeah,
get
it
it.
shifts it to the right one. Okay, let's just do some examples. Okay, Taylor series.
Oh, I see why.
Oh, Mr. Park, what's it called? Maclaurin published like a book 2 years before Kramer's publication of a generalization of the rule to n unknowns, now commonly known as the Kramer's rule. So like he addressed it before Kramer, but then Kramer.
See, but that's how it was back then. There was no like Facebook say, I developed this rule. Right? So it's like, people heard, oh, this guy's developing something. I'm gonna get in on that. I'm gonna put my name on it.
He also discovered the Euler-Maclaurin formula, which is used.
Okay, I never heard of that.
It's used for the sum powers of.
Hey, look at the time. We only got 10 minutes left.
Oh, can I go?
Yeah. You better watch the end of the video.
Alright,
Okay, you know what?
Watch the whole video.
Okay, I wanted to do 2 examples today, but why are we taking so long? Okay, write the Maclaurin series. Write the Maclaurin series for tan x. Now, we did this last year. This was on a PCH problem. Let me show you the way we did it last year.
Did anyone take pictures?
Shh. And then, if I remember correctly on the homework, it said write the first 3 terms of the power series for tan x. Now, do you remember what we did last year? We changed it to sine over cosine, and we did long division. So I'm gonna do both ways, and so you can see the benefit of both. Okay, what's the power series for sine? Okay, wait, let me call on somebody. Follow since you gotta leave, as you're walking out the door. What's the power series for sine?
X plus
Minus.
minus
X.
x squared over.
Okay.
Oh, 3 factorial. 3 factorial. 6, yeah.
X to the 5 over 5 factorial minus x to the 7 over 7 factorial, which is?
Probably that times 7.
No. This times 6 times
6
7.
7.
Plus dot dot dot. Oh, why did I? Oh, now you have to smooth it in. No, I wanted. Okay,
That was so
okay,
hard.
cosine 1 minus x squared over 2 factorial plus
Oh,
x to the
shit.
4 over 4 factorial
That's
minus
true.
x to
We
the
don't
6
have
over 6 factorial. What am I doing? Plus dot dot dot. You remember doing this last year? This was a PCH problem, or did you just copy it off the board and said, I'm the man now, I did my homework, I'm done. Apart. We did this in PCH. But you guys probably just watched the teacher copy it off the board, I'm golden.
No.
Okay, let's do long division. 1 goes into x how many times?
X.
X. Okay, multiply that times the divisor. X minus x cubed over 2. Now, we're only going to do 3 terms, because if I were to ask you to do 4 terms, that's kind of almost inhumane.
I know.
Oh, I forgot what I did now. This times that, okay, now this times this, plus x to the 5th over 24 minus x to the 7 over 720. See, that's why, when you get over there, it's crazy. It's already crazy enough as it is.
It's crazy.
Subtract!
0.
Okay, now this one.
2x cubed.
I'll give you a hint. This is like, here, I'll change it. 3 over 6.
Yeah, it's.
Subtract.
2, 6.
X cubed over 3.
1/3,
Yeah.
1/3 x cubed. Okay, now this is the same thing as 5 over 120. Subtract.
Negative
X to the
5th over 3.
fifth.
Negative, give me the coefficient though.
Negative 4.
4 over 120, that can be reduced. 1 over 30 x to the 5th. Okay, now, do the process all over again. 1 goes into that how many times?
1/3.
1/3 x cubed. Okay, so multiply that times the divisor. 1/3 x cubed, we just gotta go one more, minus x to the 5 over 6. But isn't 6 the same thing as 5 over 30? Subtract.
0.
What?
15.
We know that one's 0. Subtract this one.
Oh.
4 over 30, which can be reduced to 2 15ths x to the 5th. And then you do all over again. 1 goes into that how many times?
2
Plus 2
15ths
15ths x to the 5th. Now that's what we did last year in PCH. Anybody have a recollection of that?
Yeah, I remember.
Can you see that if I were to ask you to do 4 terms, now you're gonna involve this one over here?
Wait,
Yeah.
but now
That's
you have to,
madness.
do you have to?
No. Okay, that's the problem. Write the Maclaurin series for 10x. Okay, that's the answer.
Wait, but what if you want to write a Taylor series at center at x?
Then it's not gonna look like this at all.
Wait, do
I
I?
don't know what any of that
Okay, so
is.
let's use the Taylor definition now, except when it's centered at x equals 0, the Maclaurin series. So, you guys even, should I write it again?
No.
Oh, no, I'm gonna. F of A, but what is A?
0.
0, so F of 0,
Oh, it's the Maclaurin.
yeah, Maclaurin plus
F
F prime of 0
times x.
x plus F double prime of 0 x squared over 2 factorial plus F triple prime x cubed over 3 factorial plus F fourple prime
I don't think it's
0 over 4 over 4
I don't
factorial
think it's
plus fipple
Wait,
prime
I think
at
that's
0 x to the 5 over 5 factorial. Okay, plus. Okay, now what is our function? F of x is tan x. Hope the camera's getting this in, if not, too bad. That means we gotta take derivatives, people. Okay, let's do it over here. If f of x, oh god, we're gonna squeeze this in. It's tan x.
One long.
What is the first derivative?
1 over
Secant squared x. Oh, now it's gonna get hairy, people. What is the second derivative? Okay, let me call on somebody. Cho, second derivative. Oh, shoot. Remember I told you when you have trig functions, think of it like that, so you know you have box squared. I'm gonna call on the underclassmen, be prepared.
Oh. 2.
Box squared!
Wait.
2
2.
box to the first times the derivative of box. So that's gonna be like this then, yeah? Now we gotta do another derivative. Ooh. You know what? Maybe we just gotta stop after 3 already. Because, okay, so secant squared x is like that. Okay, who's got this one? Who's ka?
Ka.
Ooh, you gotta use the product rule, sister.
Oh. Secant.
Okay, look, box squared. Box squared.
Oh, 2.
2 box to the first times the derivative of box.
Secant x.
So secant squared tan x. Leave the second one alone, so that's that, right?
Yeah.
Yeah.
Plus, leave the first one alone, secant squared x, times the derivative of that,
Secant.
secant squared, so that's secant to the 4th. Oh man, this is hairy. Okay, you know what? Can you see the problem we're running into?
Yeah.
Taking successive derivatives is gonna be hairy.
It's hard.
But anyway, let's plug it in. And what is f of 0?
0.
0. That's the first term. That really doesn't count as a term. Now, f prime of 0. Okay, here's the first derivative. What happens when I plug in 0 into
One.
this?
Uno.
You get 1
1 squared. 1.
times x. You get
Number
x.
2.
See? So, oh, it worked so far.
Wait, this is
Okay,
3x
now,
over 2.
second derivative.
No.
Here's the second derivative. What happens when I plug in 0 here?
Why not?
You get 0 because tangent of 0 is 0. So